Hello everyone. In this video, we're going to define the work done by a force and determine its expression. So, in the first example, we'll consider a man who's trying to pull the cart by exerting a force to the right. When can we say that this force is exerting a work? As this force is displacing the cart or is moving it along a distance d. So we can say that this force is capable of doing work. Or, by definition, the work done by a force is a method of energy transfer from one body to another, or a transformation of energy from one form to another. So here we have a transfer of energy from the man to the cart, or the chemical energy stored in his body is transformed into mechanical energy. So the work is a method of energy transfer. When a force performs work, energy is transferred from one body to another one or transformed from one form into another. This example is the same as the first one, but instead of pulling the cart, this man is trying to push a box from point A to point B. As this force is moving the box from A to B or along a distance d, so we can say that this force is exerting a work. The expression of the work done by the force F equals force times displacement d, as this force is parallel to the displacement. So the force F is expressed in Newton, the distance expressed in meters, and the work is expressed in joules. So each 1 joule equals 1 Newton dot meter. What if the force F is not parallel to the displacement? It's forming an angle alpha with the displacement. Consider this girl sitting in a cart, and this man is trying to pull the cart with a force F. So the cart is displaced from A to B or along a distance d, such as the exerted force F is forming an angle alpha with the displacement vector A, B. Now, if the force is not parallel to the displacement, how to calculate the value of the work done by this force? The work done by a force equals force scalar displacement AB. So how to calculate the scalar product of two vectors? It is the magnitude of the first vector times the magnitude of the second vector times cosine the angle between the two vectors, that is the angle alpha. For example, if the exerted force equals 10 Newton, the displacement is for 2 meters, and the angle alpha is 60 degrees. So 10 times 2 is 20, cosine 60 is half, so equals 10 joules. The work done by the force of pulling exerted by the man on the cart is 10 joules. What if the displacement is not along a straight line, it is a curvilinear path, like the displacement from point A to point B? Actually, the path AB can be divided into small successive straight paths like A M1 plus M1 M2 plus M2 M3 etc. plus MN B. So it can be divided into A M1, M1 M2, M2 M3, M3 M4 etc. So the work done by the force F is the work done by the force F along AM1, so W1, plus the work done along M1, M2, W2, plus the work done along M2, M3, W3, plus the work done along MN, B, so WN, equals F A M1 plus sorry, let's repeat the expression. F scalar A M1. So the work done by the force F along the displacement A M1 plus F scalar M1 M2. So the work done by the force F along M1 M2 plus F scalar M2 M3. So the work done by the force F along M2 M3 plus the work done by the force F along MN B. So this is the force F exerting a work along the displacement MN B. If we consider F as a common, so we obtain AM1 plus M1 M2 plus M2 M3 plus Mn B. The summation of these vectors is one vector that is from A till B. So the work done by the force F equals F scalar AB. And the scalar product is the magnitude of F times magnitude of AB times cosine alpha, the angle between them. Now, if alpha is an acute angle, so the angle between the force F and the displacement AB is an acute angle, it means between 0 and 90 or 0 and pi over 2. The work done by the force is a positive work. So we say that the force F is a motive force exerting a motive work. If alpha between the force F and the displacement AB is an obtuse angle, it means between 90 and 180 or pi over 2 and pi, the work done by this force is negative. So we can say that F is exerting a resistive, so it is a resistive force exerting a resistive work. If the angle between F and AB is 90 degrees or equals pi over 2, the work done by this force is 0, so this force cannot exert any work. Why? Since the work done by a force equals magnitude of F, that is always positive, magnitude of AB, that is always positive. If alpha is an acute angle, cosine alpha positive, so the work is positive. If alpha is an obtuse angle, so cosine alpha is negative, the work is negative. If alpha equals 90 degrees, cosine alpha equals 0, so the work equals 0. If you want to consider an example, in this example, the force F is parallel to the displacement AB, alpha equals 0. So the work equals F times AB times cosine 0, as cosine 0 equals 1. So this work is positive. F is positive, AB is positive, cosine 0 is positive. So the work done by the force is positive. If we have frictional force between the box and the surface, so F is acting against the direction of motion, so it is opposite to the displacement AB. The angle between F and AB is pi or 180. So the work done by the frictional force is F times displacement d or AB times cosine pi. F is positive as a magnitude, d is positive as a distance, cosine pi is -1. So this work is negative. The frictional force is a resistive force exerting a negative work. Now, the reaction of the support N is perpendicular to the displacement D. So the work done by N equals N times D times cosine pi over 2. Cosine pi over 2 equals 0. So the work done by the reaction of the support is 0 joules. It cannot exert any work.